Now let's see how to run the multiple linear regression model in SPSS. Now this is my data set, and this data set is this is the data view of my data set. This is about the sales of various model of vehicles. These are the models of the vehicle, the column for the model of vehicles, and we have the manufacturer of each vehicle model. And we have the sales for each model of the vehicles, and we have the various characteristics for each vehicle. Now we have the type, we have the price, we have the engine size, we have the horsepower, we have the wheelbarrow, we have the width, we have the length, and we have the fuel capacity, and we have the fuel capacity of the vehicle represented by MPG. Now we want to see which of these characteristics affect or influences the sales of a particular vehicle. We might want to, that means we are running a regression analysis. So we click on the analysis menu and we place a mouse pointer on regression, and then we go to linear. Then when we place on it, brings out the linear regression model. Now for this linear regression model, we bring in a data set there. The data set we have is sales. We can decide to use the logarithm transformation of sales because the logarithm transformation does better. So we click on that, and that's the dependent variable. Then our independent variable here is the vehicle types, the price of the vehicle, the engine size, the horsepower, the wheelbarrow, the width, the length, the weight of the car, and the fuel efficiency of the car, fuel capacity and fuel efficiency. So we copy all that, we select that, and we click on this. Now, once you are done, go to your statistics, and what are the statistics that we want? We could say we need this statistics. We could say we need this, and we could say we need this. We can also talk about the part and partial correlation analysis if you want to include that. While the double waxing statistics it talks about helps you to compute the correlation. Autocorrelation, if there is an autocorrelation in your data set. So let's leave it simple for now and click on continue. Then we'll click on OK. Now once you do that, SPSS runs this analysis, and then it brings out the result. And now this first part of the result talks about the summary statistics. It's telling you that all our regression model have 69 points, approximately 69.7% variation in the sales of vehicle. But when we look at the adjusted output, it's telling us it's just only 48.6% variation in that is differences or changes in the sales of a vehicle is being accounted by a regression, by the model in a regression, that by the variables in a regression. That is the other percentage of about 51% is accounted for by other factors, So now we'll look at the ANOVA. The ANOVA is telling us that our model is a good fit because we have the F statistics of 13 points, approximately 30.3, and is significant. So we have the residual sum of square and the regression sum of square and the residual sum of square. So we can see the F statistics is significant, telling us the goodness of fit of our data set is actually okay because our model explains up to 48, almost half percent of variation in the sales of the vehicle. Now looking at the coefficients, now we have the standardized and the unstandardized coefficients. Okay, now we look at the t values here. Now looking at the t values and the significant values, you can see that the types of vehicle is significant at 10%. The price is significant at 0%. In other words, both the type and the price of the vehicle influences the sales of vehicle. Now the T statistics test the individual significance of each of the variable, that each of the slope parameter is statistically different from 0. So now we have here, you can see all these other variables are not significant. So only two variables that are significant are this, that the type of vehicles and the price. vehicle. These are the only two that actually influences the sales of the vehicle. Now we have the 95% confidence interval. We have the lower bound and the upper bound. Now this is telling you the slope of our data set. That's the slope, the coefficient of this vehicle type. We are 95% confident that it falls between this bound. It falls between this bound, lower and the higher bound for the two. Now, when we move forward to our data set, we look at the partial and part correlation analysis. You can see the zero order correlation analysis. For the time variable, it falls from this to this. You can see it actually really falls closer to zero. It's already almost zero, so it even more zero. Okay. Now, this is actually telling us that other factors that influence the sales of vehicle can be accounted by other variables. But now we look at it, the VIF, that is to check if there is collinearity in our data set. It's normally said that the variance inflation factors of 3 and above shows that there is multi-collinearity in the model. Now, for this particular case, as we can see that the lowest variance inflation factors here is 3.19. They are all greater than 3. That's to say that our model is actually influenced by multi-collinearity factors. So we can see the tolerance factor. The tolerance factor talks about the percentage. It talks about the degree of variation in the dependent variable. That's what sales are explained by each variable. Now you can see here it's almost closer to zero. It's almost closer to zero. Now to tell you that there are other factors that actually explains the variation in S, because here it's telling us that the variation in sales of vehicle that is explained by vehicle type is 0.304, and why that price is 0.187. That's what it's telling us. It's very closer to zero. That's saying that there are other factors that account for the variation of the sales of vehicle besides the vehicle type and the price of the model. Now we look at the collinearity diagnostics statistics in full. We see the engine value and all the engine value calculated. So we see the condition index, and we can see that all indicating existence of multi-collinearity in data sets. Thank you for watching this video. Don't forget to subscribe to our YouTube channel, our TikTok channel, our Instagram channel, and I'll see you next time.